Good evening, everyone, and welcome to the monthly September StAR webinar. The topic today is Materials for Rotomolding. Choice is yours. The presenter today is VENKIT MAHADEVAN, Country Manager of Matrix Polymers Limited. He handles the business in India and the Middle East. VENKIT has more than 27 years' experience in the field of specialty polymers, compounds, and master batches. Before joining Matrix in 2014, he held senior positions in Multibase, which is a Dow Corning company, and ICO Polymers, which later became part of A. Schulman. VENKIT is a techno-commercial expert who has been instrumental in successfully introducing and implementing applications for these materials in several industries in India, particularly in the automotive sector. He has much to share from his knowledge and experience in today's webinar. And now it is over to VENKIT.
Hello. Good evening, everyone. Welcome to this StAR webinar. The topic given to me is materials choice. So I named it materials choice.
The voice is a little faint. The voice is a little faint.
Is it? Okay.
Yeah. Suddenly it's become a little faint. Just get closer to it.
Is it better now?
Yeah. Yes.
So good evening, everybody. The topic today is materials choice. So I named it materials choice is yours, basically implying that for a particular application in rotomolding, generally, you are actually not limited to one particular material, many instances, So you have a choice of materials for a particular given application. That has been the case many a times. I'm not saying it is for all the applications, but most of the applications can be managed with different materials depending upon what you really expect out of the particular application or the part in the end use. So that's why the choice is yours, which you really need to understand and decide what particular material you would use for a particular application. A brief about Matrix Polymers. I'm sure all of you know. It's a UK-based company founded in 1992 by Martin Coles. 100% focus on rotational molding. There's no other business. Turnover, 6 manufacturing sites in Europe and Asia Pacific, research laboratory in UK, worldwide technical support, and global vision. These are the locations. Europe, Northampton is the headquarters, Liverpool is the lab, Kolo, Poland is the main European manufacturing facility. These locations in Australia and New Zealand. Malaysia is the closest location to India, and I am based in Mumbai, offering technical support and sales to this region as well as Middle East. Okay, so talking about materials, we obviously have to start with LLDPE. So LLDPE, we all know, is the most popular and widely used material. There are reasons to it. The basic reason is that it is easily available, very easily available, produced by several companies across the globe in several continents, locally available. Mostly the standard LLDPE is usually sourced locally by almost all manufacturers across the globe in each country, in each continent. It's relatively cheaper. It is very easy to process. It has got a very wide processing window. It needs relatively low temperature controls, etc. It is easy to pulverize, easy to color, etc., etc. So all these make LLDPE the most user-friendly material for rotational molding. It's a fantastic material. No way to do away with LLDPE. It's an important material for the industry. It is important material for rotomolding per se, but it is a fantastic material. But having said that, there are certain limitations for the standard LLDPE. Like the maximum operating temperature, it cannot go beyond, even 80 is a little tricky with, you need to achieve this with structural reinforcements, etc. but ideally 70 degrees is the maximum temperature that is recommended for the standard LLDPE. It's not very stiff. We all know the tank manufacturers particularly will agree that the problem of bulging is a particular typical problem always with the standard LLDPE, particularly for large parts. It's not very suitable for large parts. It's a soft material, so it gets scratched easily. If there is a crack or tear, the propagation of the crack tear is pretty fast. It is quite compatible for potable water, but then not so good for other materials that are usually stored like chemicals and acids. So the properties that are not satisfied by standard LLDPE are stiffness, the load bearing capacity, very long-term durability, scratch resistance, higher temperature conditions, higher impact resistance. It's if you need very good ESCR, resistance to acids and chemicals, resistance to diesel fuels, etc. There may be others. So that is the gap or void that we need to fill with other materials and understanding other materials and choosing them. So we need a range of other materials to meet these additional requirements. What are they which are available as of now? Hexene, octene, comonomer, PEs, HDPE, which Matrix calls as a superlinear high density. We also need to really define what is an HDPE. Generally, the materials which are higher than 0.940 density are referred to as HDPE. Different perceptions, as there are no standards to define what exactly is an HDPE or what exactly is an MDPE. So HDPE is one range of materials. Cross-linked polyethylene, of course, polypropylene, polyamide, polycarbonate, plastomers, rotolining materials, etc., etc. These are the other materials that are required other than LLDPE to meet the requirements. We will see some of these materials, how they can be used, what are the criteria for choosing a material for a particular application. So generally, when we choose a resin for an application or for a particular part, what are the properties that we look at? What are the features that we look at rather than properties? So UV stability, stiffness, toughness, strength, processing window, cycle time, ESCR, color. By and large, these are the properties that we need to look at. And many of these properties, you all might know, are contradictory to each other. They are inversely proportional to some of the other properties. So that is what really poses the challenge in choosing the right material for a particular application. So there is this balancing act. So these slides are worth spending a few minutes extra. So we can see that an MFI of 2 to 8 or 8.5 and density of 930 to 945 is a traditional range. And then we can see that when we go lower on the MFI, the processability becomes difficult. And when we go much higher on the MFI, the mechanical properties deteriorate. So this is the balance that we need to strike as to between these are the conflicting properties which we need to really understand while selecting a particular material. Similarly, when the density goes up, chances of warpage increases. And when the density goes down, the material becomes soft and the so-called bulging or lack of stiffness happens. So there are two slides which will basically summarize the properties, versus the two main features of a resin called as density and MFI. So this slide, I think, I'm sure is quite familiar. Most of you would have seen this many times before, but it's just a summary. These are the basic way the properties behave when the feature called density varies of a particular resin. Take a standard resin and assume that every other thing is kept constant and the density varies, then this is how the properties will vary accordingly. One property, weatherability in general, is not affected at all. But then as the density increases, the impact strength reduces, the ESCR reduces, optical properties reduce, and the ductility of the material reduces. Whereas shrinkage increases, stiffness, of course, increases, tensile strength, hardness, HDT, barrier properties and chemical resistance, all these properties increase along with density. So this is the conflicting nature of the properties with reference to in connection with a particular feature of the material called density. Now, similarly, when we look at it for MFI, so yeah, so again, you know, here when the MFI increases, of course, it is very easy to process. When a higher MFI material is easier to process, it easily flows into all the minute parts, intricate parts. Stiffness, hardness, and barrier properties are not largely affected by the melt index MFI, but impact strength. You go higher on MFI, it will be easy to process, but impact strength, ESCR, weatherability, chemical resistance, tensile, and ductility decreases. So later on, probably we can revisit this site if required during the question and answer session or something like that to understand this a little bit more. So if you look at it carefully between these two slides, there are significant properties of the end product or the target properties of the end product which go extremely contradictory versus one another. So that is where the challenge is in choosing a material. So that's why the whole process is a balancing act. Now, then we have also the molecular weight and the chain length as factors which decides, which will determine the performance or suitability of a material for particular applications. So we all know that nowadays C4, C6, and C8, the butene, hexene, and octene are available. As you can see, the processability, of course, because all these materials remain the same, so there is no issue of processability. Whereas stiffness increases, ESCR increases, impact strength increases when you move from C4 to C6 to C8. Similarly, if you look at the molecular weight distribution, the broader the chain, you know, the processability increases, so the processability decreases, whereas ESCR and impact again, you know, move contradictory to each other when the molecular weight distribution is increasing. So these are all the factors which really, it is very difficult to summarize all of these in one slide. I don't know anybody has attempted that so far, but it is very difficult to summarize all of this in one slide. So that is why we need to have a clear understanding of how these properties behave with respect to a particular feature of the resin. So this is an illustration of the hexene versus butene. We all know that the hexene has got a longer chain, which is what offers it, and similarly octene has got even longer chain. So it is C4, C6. There are the 4 carbon atoms versus the 6 carbon atoms versus the 8 carbon atoms. So these are the features which impact or provide that extra property benefits to those resins, whether it is hexene or whether it is octane for that matter. So what are the key properties of hexene? Now the presentation, just to mention here that now the presentation will move into the technical aspects in general. The textbook aspects is what we saw in the previous slides. Now we need to really correlate with what are the materials which are commercially available in the market or easily accessible and available in order to understand how to utilize those property features, you know. So that is why this now moves into the available material. So hexene is now very popularly available, very easily available. We are ourselves offering that. So yeah. So the hexene grades offer significantly better mechanical properties in terms of toughness, impact resistance, and flexural modulus. It is much better in creep resistance. It is much better in ESCR. It is, I mean, ESCR essentially also means that it is the crack propagation and failure is resisted to a large extent in comparison with butene resin. So we also need to understand here that we need to have a apple-to-apple comparison. These properties need to be looked at, assuming that the other properties are maintained constant. It is very important to understand this. So, a better, for example, a better toughness can be achieved, the hexene is not the only route to achieve that. If you need a better impact resistance or a toughness for a particular part, there are various options. That's why, as I said earlier, the choices, there are several choices. So you need to really understand which is the most suitable route to achieve that. Of course, as also keeping in mind the commercial aspects of that, which of course we may not take up for discussion here, but then the technical aspect, technically this is the concept of that. So one particular property can be achieved by different methods. A hexene is one option, a higher density is one option, balancing between a density and MFI is another option. So this needs to be understood. It is nothing of these is absolute to one particular case. So this is the material offered by Matrix. Revolve 6329U is a very popular material now, widely used in India, in Middle East, in other parts of Asia. It's a very popular material. So we have case studies of up to 15% short weight reduction without compromising on the features and performance of the part. In fact, probably making a better part than the same part being made in a butene resin, So we have typical case studies of short weight reductions, which is an advantageous feature commercially also when you look at using a hexene resin to have a better part made. So typical applications, underground tanks, you can see that very tall tank, which is a single layer tank, no stiffness, no bulging, extremely tough and durable. I mean, these are typically chemical tanks, so it has got outstanding chemical resistance. There are no structural features in the design, if you see. There are no structural features, it's a single layer tank, so that is possible by only because of the features of a hexene material. Underground tanks, of course, withstand heavy pressure load from outside and inside, and it has to be heavy duty and long-term durability. ESCR is very important, so all these things are taken care of by a good hexene resin. Now, this range of materials called superlinear, they are essentially very high density materials. These are available commercially, and we need to see where are the applications that they can be used at. So these are, you can see that the densities range from 0.945 to 952. MFI is relatively low, kept low, so that ensures that the toughness and the mechanical properties are good, as well as the stiffness and the other features of the higher density are availed in these materials. So high density grades up to 952 gram per centimeter cube. Stiffness because of the high density, exceptionally tough and durable, high impact resistance, long operating life, scratch resistance, UV8 to UV20 possible, very easy processing, no special processing care or processing parameters required, colors possible easily. These materials are typically used in the marine leisure applications like the kayaks and the boats. We have several customers using these materials in Australia and Europe. Not many in India as such, but then we hope to have such applications in this region as well in the future. Cross-linkable polyethylene, we all are familiar with, I presume now. 10 years back when I started with POLYMERS, cross-link polyethylene was not a very known or familiar or popular material in India. People were aware of it, but have not experienced it, have not used it. Now there are several companies in India using cross-link polyethylene extensively for automotive applications. So let us understand a little bit about this material. So cross-link polyethylene is nothing but the red cross-linking chain that you see in the molecular illustration, the structure, the molecular illustration of the material. So normal PE and the cross-link PE. The cross-link PE basically has cross links between the polymer chains, which is what gives its extreme strength and toughness and all those very high properties that it has. The cross-linking occurs when the activation temperature is achieved within the rotomolding mold. There are these strong bonds generated and between the molecular chains, and it is during the heating stage of the rotomolding process. So what are the key properties of cross-linked PE? Now, when we talk of some of the properties like toughness or strength in general, there are not very definitive measures to actually define them in a range like impact resistance or temperature resistance. So we need to. So you might see this toughness in reference to 2 or 3 properties. This again reiterates what I said at the beginning, that you can have different materials for the same application. We have cases even in India where for a particular model of a diesel tank, the company uses MDPE for one particular market, and they use a cross-linked PE for another particular market. Sometimes it is difficult to explain the logic behind that, but could be commercial reasons. But technically speaking, again, the fact is that both are okay, both are suitable, both are fine. Depends upon what is the final deployment or usage conditions that these the parts will go through. So toughness, very good impact resistance. Sorry, that's a mistake there. Impact resistance and temperature withstanding capability from -40 to 80 degrees. Chemical resistance meets global diesel permeation standards, including in India. Of course, Indian standards are an adaptation of the European standards. So once it passes the European standards, it easily passes the Indian standards as well. Resistant to flame tests as specified in the fuel tank specifications. Excellent ESCR, resistant to temperature, resistant to fatigue, and very long-term durability. These are the key properties. Sorry for that mistake here on this line. It is supposed to be another line with the temperature. So you can see the difference between the impact performance of a crossing polyethylene. The red is the XL400 crossing from matrix, and this is you can consider a standard LLDPE. It is much higher than as normal LLDPE. That's why it is used for the fuel tank application. Flexure modulus, again, particularly to note the black bar, which is across all the temperature conditions, XLPE performance is very, very high. But particularly at higher temperatures, XLPE behaves much better than the other materials, including the hexene for that matter. So these are some picture examples of fuel tanks. Diesel tank, this is diesel tank made in Italy, XL400 black. This is a motorbike fuel tank. Motorbike fuel tanks, yes, essentially they would be sometimes dual layered with a nylon layer inside to meet the permeation conditions of gasoline or petrol. Some examples of paintability, colored fuel tanks for motorcycles. Chemical container for the aviation industry. Now polypropylene. So PP is not so common in rotomolding. Why? Basically, is it lack of availability? I think it is lack of availability. There are not many PP grades available easily for rotomolding. Difficult to mold. Well, it can be improved. It has been improved quite a bit. Poor impact resistance, again, can be improved, has been improved. It is as such, it comes expensive than PE, but maybe it has to do with the overall volumes also, and the knowledge about where exactly to use PP. So would you like to replace the standard LLDPE with PP? Probably not. At this stage, there are not so many options. There are not so many practical, viable options to do that. But then moving forward in the future, to some extent, maybe yes. So let's see what are the properties of polypropylene. So polypropylene essentially, at least as far as rotomolding is concerned, has to be considered only where you need high temperature resistance. Higher, when I say high temperature resistance, higher than what LLDPE can offer. So up to 100, 110 degrees, it is safe to use polypropylene. It has got much better scratch resistance. It has got high stiffness and high flexural modulus. Chemical resistance, it is of course a little difficult to mold, and of course it has got relatively poor impact. But in the current scenario, these deficiencies, if I may use that word for want of a better word, these deficiencies of polypropylene have been addressed to some extent with modified compounded grades. So that's an example of a polypropylene header tank, light globes, lighting systems, where due to the heat from the lighting system, the polymer also needs to withstand the higher temperature. The ambient temperature goes up. Nylon, excellent hydrocarbon barrier. Excuse me for a moment to have a sip of water. Nylon polyamide PA12, for example, excellent hydrocarbons barrier. It is suitable for petrol or gasoline, whereas XLPE, cross-linked polyethylene, and other materials are not suitable for petrol and gasoline as per standards of the different, mainly the US and the EU standards. Excellent chemical compatibility, good impact resistance. Nylon is paintable, much better paintable than, I would say, much better paintable than any other material. It has got high stiffness and, of course, high operating temperature resistance. High temperature, outstanding barrier, paintable, UV stable, easy to rotomold. So these are dual layer petrol, dual layer motorbike fuel tanks, as I indicated earlier. Nylon inside and cross-linked polyethylene outside. So polyamides are easy to mold. They're a lot more expensive than LLDPE. This slide seems to be a repetition, but this helps expanding the range of products that you make if you can consider polyamide for certain applications. So you can see the permeability with related to other materials. So this is essentially the amount of material that permeates into the fuel. So that's why the red, which is very, very low, is much, much better than a normal HDPE, So this is grams per gram millimeter per square meter per 24-hour, whatever, So that's the, it's essentially the particles, the amount of particles that migrate into the fuel, the amount of polymer particle that migrate into the fuel. That's what it indicates. That's what makes it suitable for petrol. Temperature resistance, of course, it is much higher than it can easily withstand up to 125 to 130 degrees temperature. Polycarbonate. Well, to me, polycarbonate is a material which is to be considered for aesthetic applications where you need a transparent part. It has got excellent clarity. It is very rigid. It can be UV stabilized for outdoor use, good impact resistance, etc. So it also comes with flame retardancy. So that is one advantage of polycarbonate. So it's not suitable for chemical and ESCR applications. Very little shrinkage. The processing is a little bit challenged. I know some customers, some molders who have in India who have taken trials, but have been successful as well to a large extent. Example of a light globe again. We have applications like large outdoor garden planters, etc., made with polycarbonate. That's another application. I don't know where it will find. So what Matrix does? So Matrix identifies the areas where there are gaps in material availability in the market, and work on those areas and develop, source, adopt resins and modify them to make them suitable for rotational molding. I often keep getting demands for a material ABS. Is ABS available for rotomolding? As such, we don't have, but my technical team is on it trying to develop an ABS material. I don't know either any other sources also, but as of now. So these are the type of work that Matrix does, trying to fill the gaps wherever when it comes to materials. So this is a quick summary of the choice of materials application wise. Small and mid-sized tanks up to 2000 liters, butane LLDP is the best material, nothing to beat that. Mid-sized to large parts, 5000 liter tanks above, underground tanks, single layer tanks, you will consider hexene, octene, metallocene. High temperature applications, polypropylene, very strong and tough parts you need, so superlinear, the very high density, or XLPE. Fuel tanks, diesel, biodiesel, hexene, MDPE or XLPE. Fuel tanks, petrol or hydraulic tanks, pressure vessels, PA12 nylon, clear transparent parts, polycarbonate. So this is the summary of the topic of materials. Choice is yours. So to conclude, I am not sure I finished early or late. I think I'm on time, around 20 minutes. So these are the contacts. Aldo Quarantino is the technical director of Matrix Polymers based in UK. I'm sure most of you are quite familiar with him. He has visited India quite often. He visits India quite often. And thank you. Zaman?
Thanks, Venkit. There will be questions now. Please ask your questions. Questions can be asked by clicking on the hand icon. Any questions?
Or comments? Not only questions.
Yeah.
Comments, alternate thoughts. Welcome.
From Mr. Prashant Trivedi of Syntax. Just a moment, I'll unmute him. Yeah, Mr.
Good evening, Venkit. Good evening, Venkit. Prashant here.
How are you? Prashant, good evening. Yeah. Thank you. Thanks for participating.
Thank you for a very informative presentation. Only one request that I would request you to come again back for another webinar, particularly showing us and advising us on the processing parameters and more of an application, because when we are typically working on different materials in a conventional rotomolding industry, processing becomes a very, very difficult task, and people are not able to get consistent product out of it. So I would suggest that while showing the grades of material which can be recommended for different applications, some processing parameters and conditions and the boundaries needs to be also would be a great help to the processors in rotomolding in India.
Absolutely, Prashant. Very good point. We do have, in fact, I do have a presentation on processing of all these materials also. But then since the topic was choice of materials, so I didn't take that. So very good point. Absolutely, we can have one presentation where we will discuss in detail the processing parameters and what are all the challenges in processing each of these materials.
Yes, that would be very beneficial to the rotomolding industry and people who are being part of this webinar.
Absolutely. Thank you very much. Very valid point. Zaman, please note.
That will be coming up soon.
Hello?
Yes, that will be coming up soon.
Yes, has to be, because that will help a lot of people once we are going beyond water tanks. I think the matrix material has shown beyond water tank all of the applications except the big tank of 30,000 liter.
particularly the polyamide and polycarbonate need definitely need different process conditions and parameters which we have already faced. So definitely that is a very valid point, Prashant. As always, it is a very ideal topic for another webinar. Sure.
Another point which I would like to stress upon is that India mostly people know butene and octene. I think you need to also give a stress on hexene material, which is a fantastic material. So people are still not aware of this hexene material and its application. A lot of confusion is there that the material between butene and hexene, octane hexene has some inferior property than octane, but I don't want to say that, but there are some positive points also with hexene than octane material. So we need to stress upon those points and see the applications.
Sure. So one comment what I would make there is that, see, definitely theoretically when you look at it, octane is better than hexene, right?
Yes.
And hexene is better than butane. So as I said earlier, the absolute comparison becomes relevant and valid only when you compare keeping every other thing constant, right?
Yes. Right.
So that is the point. So finally, it will all depend upon availability as well. So hexene, as such, is produced. I mean, next to butane, hexene is the material which is widely produced and available when you look at the overall global scenario. So availability and cost. So, for example, let me put it this way. You have ABC as I mean, or hexene plus X is butane plus X is hexene, and hexene plus X is octane. When I say X, the X benefit. Okay, butane plus X benefit is hexene. Hexene plus X benefit is octane. Now, to achieve the first X benefit, to go to hexene, there is a cost. There is a cost and there is a process, overall process. And then compare that to the additional X which you need to go to octane. This is a topic, of course, discussion for the big petrochemical people, but still to try to make it understand simply what we also face when we go around sourcing for an octane material. The problem is that since the volumes and the benefit versus cost is not justified, hexene becomes the easier choice. You know, it is not that octane is so then but then the fact also is that hexene meets most of the requirements. Maybe there are some specific cases where octane might still be better. It's a choice of an ascending progression, continuous progression, you know. So hexene meets most of the requirements when you want to go to the next level. So that is why hexene is popular now. That's why it is also available easily. I hope I made sense what I said, Prashant.
Yes, yes.
Thanks. It is easy when all the people are known in a webinar, you know, so you are much more free and easy to talk and discuss like across the table.
That's true.
Okay. Any other questions?
Thank you, Venkit.
Yeah, Mr. Sachin Vaigaonkar from BITS Pilani. Go.
Oh my God. Good evening, sir.
I'm sorry.
Hello.
Yeah.
What happened, Venkit?
Hi, good evening, sir.
Good evening, Venkit. What happened?
No, you asking question and I answering is kind of a irony, you know.
No. I'm also a student of Rotomoulding. Don't please.
Tell me, sir.
Thanks for very excellent informative presentation. And actually, Prashantji has actually asked my question. So I just want to append for that recently we have actually came across your material, or I don't know, but which was we have found out the melt flow index was around 2.8 or between 3, somewhere in that range. So I wanted to just know that whether the same PIAT during the processing should work, or we should increase the PIAT slightly so that the material flows of this particular less MFI.
Okay.
This was around 3, I have observed 2.8 to 3. I have not sure. So
okay.
it's
yeah. So, sir, to be honest, I will have to pose this question back to my technical team. But to the extent what I can address it, you know, it is because of you are referring to a hexene grade, or you are referring to a butane grade?
No, because that information I did not have. I have only tested the melt flow index, which I have found it to be 2.8.
Okay. So to the extent
it's a very less, it's a very viscous.
to the extent what I can address, the PAT need not be altered because of a change in MFI. Probably, PAT is not the way to, if you face a little bit of a flow problem, the PAT is probably not the factor to address or to be altered, So this is what I feel. But as I said, to be honest, I don't want to take up a technical point without actually knowing it fully. So this is a process related question. So I'll definitely post it back to my maybe Mr. Aldo, and I'll get back to you, sir. Any Prashant, you might be able to comment on this a little bit, if at all. Is Prashant still unmuted?
Yes, basically when the MFI is low, it's very important that yes, you have to slightly increase the PIAT. It's important because rotomolding specifically works on flowability. So when you are using a lower MFI material, by 10 to 12 degrees or 15 degrees C, you have to increase the PIAT so that you are able to manage the flow of the material. That's what we also.
Prashant, you are referring to the PIAT or the oven temperature? These are two different things. So
anything. See, if you say PIAT also,
internal temperature needs to be increased.
Okay. Good, very good question. I think I will try to answer you and all the attendees, of course. Once we have
I want to say that we
this.
cannot process this material in the same way as we process, let us say, the other general normal 935 grade LLDP. So you can just focus on this, and whether this polyamide is in the powder form or it is liquid, because many times this
polyamide is in the powder form. Our polyamide is in the powder form.
Okay. Fine. Thanks.
We also
thanks,
have
Venkat.
nylon 6. Yeah. Thanks, sir. Thanks for the question. I'll come back to you on this for sure.
Yes.
Please share with me as well.
Sure. I'll send it to Jaman. The question is, it's in the board. Everyone should get the answer.
In fact, the StAR is thinking to bring us together on the same platform. We should thank StAR.
Absolutely.
Yeah.
Now Mr. Rafi John from Evolve Polymers would like to ask question.
Venkat, Rafi here.
Hi, Rafi. Good evening.
Very good evening, Venkat. I was just seeing your presentation, and one doubt that always raising to me was, I make a particular article out of the normal LLDP that is available in the material. I make an article from matrix polymers of butene and OP for my underground tank application. A particular size or a particular thickness, everything the same. What all test, if I do on it, will show that your product stands far superior than the product that is available here.
Okay. Good question, Rafi. So, see, generally, I will take I don't know whether I can apply it across the board, but the general case studies that we have conducted to assess the benefits of using a hexene grade, for example, you replace the standard butene with a hexene grade. There are case studies, couple of them actually are from India. I often refer to all of the customers whom I meet when I discuss. There is one case study where there is a crate. The part is a crate, and this crate has been it's a very abusive or a very, very aggressive usage of the crate. There has been severe problems of breaking and cracking of the crate in actual usage, actually deployed usage. So they did this particular customer did a drop test. It's not as per any standards. It is nothing. It is just as per their own process flow. So this drop test is nothing. You just take it to a particular height and drop it, and keep on dropping it until it breaks, or until it cracks, or at least initiates a crack. Okay. So what used to happen? The numbers may be a little bit here and there, but to give you a rough idea. So this particular grade with a standard butane used to crack at average about 12 to 15 drops. Nothing happens to it until 10, 11 drops. 12 to 15 drops it used to crack, right? Now, the same material, the same drop test, the same similar average when took it to 18 to 20 drops. So it has survived that many more drops to that is what you can infer out of it. Now the fact is also that this particular crate, the weight of the material that they used in the standard butane was about 8% higher than, so they reduced the weight by 8%, and still the crate sustained few many more drops, you know. So
No,
what does
I
this
would beg
indicate?
to, I would beg to differ there. I would beg to differ there. Once you reduce
Okay.
the weight, the impact strength rather increases because it's become more thinner. So that's the chance of it cracking reduces a lot. When the
Well,
article
I
is
am not
thinner,
sure
when
of
the
that.
article is thinner, the crack it is more crack resistant. When it's thicker,
Not
it's
essentially.
prone.
Okay.
Okay. So let's put those. Okay, because I wouldn't, because maybe it didn't crack because it was thinner.
Okay. Now we can do a test without reducing the weight. Okay. Obviously, they would have done the weight drop test initially without weight. Nobody would reduce the weight at the first instance.
No,
Okay.
since you mentioned it, I was just telling. Okay, now
Exactly.
so if you could give me some things that, okay, you make an article out of my material, you do these tests. If the other thing breaks at 10, ours breaks at 12, or whatever you can substantiate and give me a test report, it would be very good. And my next question to you is hexene. Yeah, hexene and octene grade which you're giving in the colored form. Is it possible for me to get in the pellet in the natural color form, and I color it at my end? Because what happens is
the hexene is available as natural granules. All the people are buying as natural granules. Since Prashant buys it as natural granules, it's available.
Okay. It's available, right? Okay. And plus this test results, if you can give me, that it will stand better.
Yeah.
I would just.
So regarding the test results, Rafi, just to make a point there, unfortunately, as we all know, none of these properties other than the arm impact test can be tested on a rotomolded specimen, right? So to make a comparison, you really need to figure out your own test parameter procedures.
No, you were mentioning you're mentioning about ESER and all those other things also on this.
Yeah, all these are standards which are for the, if you really need to test it exactly as per the standard, you cannot take out a specimen from a rotomolded part. The specimen has to be prepared the way the particular standard is specifying it, you know. So that is why most of these have to be for rotomolding. That's perhaps a limitation. I don't know. So we can hope that more standards are developed with rotomolded specimens to be able to test other mechanical properties at least as well, if not others. So so that is where the issue is. So even if you many cases I have seen that the rotomolded specimen tested shows much different values than the datasheet values, because the datasheet values are prepared as per the standard from the specimen prepared as per the standard from the granule form or whatever process it is specified. So these are yeah. So that is one issue. That's why yeah. So that is why I will say that, for example, take the case of applications like diesel tanks and fuel tanks and automotive applications, where because those are application sectors where standards are followed much more diligently than other segments, you know. So the standards developed by for automotive parts, for example, a fuel tank, are are for the tank. They have been developed, defined, and specified for the tank. It has got nothing to do with the other standards, which are ASTM and other standards for the material. So unless we have some standards to test the molded parts, in the rotomolded parts specifically, and to establish that point, what you are suggesting in absolute terms is not possible. So that is why we need to resort to these kind of drop tests or similar other tests which are relevant to that particular. This is my opinion. I see that Akshay is also there. Probably Akshay can also make a comment. Automotive parts do have standards. They have developed their own standards to be able to determine the suitability or the performance of a rotomolded tank. That's why XLPE and the special grade PEs fuel tanks pass, whereas a normal butane grade tank sometimes fails or does not pass to some extent. Zaman, anything else?
Akshay, any comments here?
Yes.
Yeah, please.
Yeah, so I agree with everything he had to say. To start off, Mr. Venkit, fantastic webinar, loved every slide. I took the liberty to screenshot a couple of slides which were very informative.
No problem. Welcome. I can share this, Akshay.
Okay, and with regards to the automotive standards that we're talking about, yes, usually most of the auto companies would ask us to get our parts homologated, so which would be based on validation and approval from an industry association like ARAI, a testing association, which is the Automotive Research Association of India. But sometimes, I would say rather more often than not, a lot of these companies will also do internal validations along with the homologation of the parts, which would be based on their own internal standards of testing these parts. In the case of some MNCs, this would be taken off from the parent company. So we work with a tractor manufacturer called John Deere. While they insist on ARAI homologation, they will also do a very thorough and exhaustive testing internally based on Deere and company's own internal test standards for molded parts.
Yeah, so that's it. The point is that they have their own internal test standards. The specimen taken out from a rotomolded part tested is probably not a feasibility to exactly determine whether that particular material is offering a particular benefit in terms of property or not. That's the moot point. Yeah. Okay, but that's again, Rafi, definitely that's an interesting point. I know that we have been discussing this for a long time. So I will definitely have taken it again as a topic for internal discussion and development. What can we actually do to really experience and establish that a hexene molded tank vis-a-vis a butene molded tank is better or not? Right?
Yeah, Mr. Tarkesh Patel from C Plus would like to ask some question. Mr. Tarkesh.
Yes.
Hi, Tarkesh. Good evening.
Good evening. Good evening. Venkit, is this XLP is food grade and available in natural color?
No. Yeah, XLP is not food grade, Tarkesh. XLPE doesn't, we can't give the FDA confirmation certificate for XLPE, but it is available in natural color, for that matter, any color.
Okay.
Yeah, it is available in natural color. Of course, people buy it in natural color as well as black, gray, or red or blue or any color you want, we can supply, provided the commercial volume requirements need to be met. But natural is not a problem. Natural and black are standard as regularly available, easily available.
Okay, okay. Thank you. Thank you.
Thanks, Tarkesh.
No more questions. I think we are done for the day. Thanks a lot, Venkit, and everyone else. We had a very good webinar and look forward to seeing you all again next time, next month. Thank you.
Pleasure. Thank you all. Thank you.